Welcome to Module 5, Part 1. In 14.1, we're just going to cover some basic vocabulary. The word enumerated means counted, and we're basically trying to figure out how can we count things around us that we're interested in. Two big terms we're going to be talking about a lot is population and sample. You will actually be conducting a survey in this module, and so first you need to figure out your population. This is the big who. So maybe it's all people, maybe it's just Americans, maybe it's women between the ages of 18 and 30. So your population is your big who, and then your sample is of that big who are you actually asking the questions to? Now, in a survey, you're actually asking the sample to determine something about the population. And the thing is, in a survey, the idea is we would actually want to ask every single member of our population, but it's going to be really hard to ask every single American a question. So instead of asking every person of the population, we take a sampling, or we find the sample that we can actually reach out to that's a good enough representation of the population, and then we can make an inference or a prediction about the behavior of the group as a whole. So say we wanted to conduct a poll about an election, which is a really common thing. So the population would be all voters, but how can we identify who is and who is not going to vote ahead of time? So we know who the registered voters are, but among this group, a lot of people who registered don't vote. So the first important step is to actually distinguish the population or the target population. And then from there, we'll draw a sample. And the ideal scenario in a sampling frame is the same as the targeted population. That would mean every member. But again, it's just not really practical or possible, so we have to use a sample. Okay, so let's look at an example of the sampling making a difference. So a poll was conducted right before the 2004 election. If the election was being held today, who would you vote for which kind of candidate? And so there were 1,800 registered voters that were asked, and these were the answers that they gave. But the exact same question was asked to likely voters, and this was the answer that they gave. They're not the same. So the difference between the two was who they asked. So who you're asking makes a really big difference in how your answers will be found. Feel free to pause this video at any time and read over the slides or follow along with the slides posted in Canvas as well. So again, why don't we just, always ask the best people, the likely voters? And the reality is it's really hard to find who's likely to vote. It's much easier to find the registered voters because they're registered. We have their information and we can ask them questions. So we have to remember that just because an ideal population is created, an ideal sample isn't always possible. And that really does affect those poll numbers that we read. So, okay, how do you sample? So we want to find a sample that's representative of the population. We want to determine how big the sample should be. A very small sample is not a good idea because if we only ask a couple people, we're not getting a broad enough example of the whole population. We really want to get as many different kinds of people within that population, different economic backgrounds, different places they live, different areas, if that meets within the population. Let's take a look at this example. The U.S. presidential election of 1936 pitted Lyndon versus Roosevelt. Now, this is a really famous poll. So what happened was the Literary Digest was a huge magazine at the time, and they had used this magazine to accurately predict the results of every presidential election for the past 20 years before this poll was taken. So here's an enormous list of people. It had every person listed in the directory, every person with the magazine subscription, and every person of a club. They had 10 million names. Talk about a really big sample. And they mailed it out, and they asked it to mark it and return it back. So based on the results, Landon, a person you've probably never heard of, got 57% of the vote. But what ended up happening was that guy didn't even get close. And this was the largest error ever in public opinion poll. So what happened? Well, who are they asking? Let's go back to that population. People that listed themselves in a directory, people who subscribed to that magazine, and people that had professional associations. That's not indicative of the entire population. So when it came to the economic status, it just wasn't true of the full population. And so the other problem was it was a self-selection bias. They mailed it out and only the people who wanted to respond did. And that's not an accurate way to gather a survey. The response rate and the non-response rate. So just because they had a huge size of sample doesn't necessarily mean that you're going to get an indicative response for the population. So just because you have a big sample doesn't work. You want a well-chosen, big enough sample, and be careful for the selection bias and non-response bias. So now let's talk about how you could sample. So there's convenience sampling. This is a shortcut. Basically, you're standing wherever is the most convenient where your sample could be, and you're just asking people. You're standing at a fixed location, and you're getting answers in a convenient manner. It's the cheapest, quickest way to gather data. Problem is that it's self-selection. People can decide whether or not they want to participate, and it's not always bad, but it's not always good either. Quota sampling. So with quota sampling, it's a systematic effort to force the sample to be representative of a given population through the use of quotas. So the sample should have so many women, so many men, so many people of color, so many whites, so many people living in urban areas, so many people living in the country, and so on. And so you're saying, okay, I'm going to ask all these different people that are indicative of the population, and then have equal proportions in the category and go from there. We've got another case study here. I'm going to let you take a moment and read through these. Simply pause and go through. So in that example, you can see that quota sampling just doesn't make the most sense because there's just selection bias and it's not always a good representation of the whole. Random sampling is great, but random sampling is not always easy to do. And finally, we've got stratified sampling. It's similar to random sampling, but what we do is we break our categories into strata. So for example, maybe you're looking at women 18 to 35, so you're going to break it up into substrata, maybe where they're located, or race, or language, or area codes, things like that. So you're breaking up into different strata. Finally, we want to talk about cause and effect. So a different type of data collection is needed when we're trying to establish connections between cause and effect. So does taking a math class increase your chances of getting a good job? So we're trying to see if there's a relationship between the two actions. They can't really be measured by answering a question. This is something that you want to watch over time. So these kinds of studies are a little bit different. We're looking for a relationship and association between X and Y. And we have to remember that just because something is related doesn't mean there's causation. And this is a really important thing. One of my favorite examples is people can say ice cream sales cause more murder. But really what actually is a real statistic is that when temperatures rise, there is an increase in crime. What also happens when temperatures rise is people buy more ice cream. So what someone could easily say is that there's a relationship between ice cream and crime, but we know that that's just not true. So we have to be really careful about association and causation. So here's an example. There was a chemical used by apple growers, and then it was denounced in the newspapers as a cancer causer, and everyone stopped buying apples, and there was money loss and all different kinds of things. And it was based on a single study in lab mice. And the dosage that was given was actually 8 times greater than what was actually tolerated. And take a look at this. If a child were to eat 200,000 apples, it would be equivalent to that dosage a day. So what does that mean? It means that we have to be really careful when we consume statistics in the media or when we consume statistics in general. That one study, we have to be really careful that we're looking at alternate studies, that we're looking at who funded the study and things like that. Because what ended up happening was there was huge loss in an industry, huge changes, huge horrible things. And it was basically a false alarm. So we've got clinical studies and clinical trials. A clinical study is when we're trying to determine whether a single variable can cause an effect. We want to be really careful about how we're conducting clinical studies. And we want to make sure that we're isolating the cause as much as possible. In a controlled study, we've got the treatment group and a control group. The treatment group is receiving the treatment, and the control group are not receiving the controls. Are not receiving any treatment. The goal of this is to really determine a cause and effect relationship between the treatment and non-treatment. Again, make sure you're pausing here, reading over these slides. Now, something that's really common is the placebo effect. It's pretty common in what we talk about. It's this idea that there's still one major difference between the two groups that can significantly affect those control groups and treatment groups. If you think you're receiving the treatment, you might feel like you're getting better. Just the idea of treatment can produce positive results. So we have to be really careful about how we handle placebo effect in control groups. So in a controlled placebo study, a placebo is that make-believe form of treatment, and a controlled study is when the subjects in the control group are given a placebo. A blind study is really good to control placebo effect. So it's a study in which neither the members of the treatment group nor the members of the control group know who is in the blind study. So they don't know anything about it. And then the double blind is when the scientists themselves don't know. So I encourage you to go to page 430 to read about another vaccine field trial that really had a deep effect on the way that we conduct these kinds of studies. And that concludes part 1 of the module.